On ktalk.co.za,
on the app,
on DSTV channel 885,
and across the city on 567 AM.
Join the conversation.
This is Cape Talk.
This is Cape Talk.
I think it's been 2 weeks since I last spoke to Dr. Chris Smith, the naked scientist. I've missed him, and I mean it sincerely. Chris Smith, it's been more than a fortnight since I last spoke to you. How are you?
I'm good, and I've missed you too, and it's good to see you back.
Let's not waste the listeners' time and jump straight in. Ian in Berkfleet, good morning.
Good morning. Thank you very much. My question refers to time and light. We know we can't go back in time, but we look back at time whenever we gaze into the sky because light travels. Is it feasible that science could develop a transparent material, call it glass, which would slow down the light traveling through it so we could witness on the other side of the glass events from an earlier time?
Fascinating question.
Ian, we sort of already can do that in the sense that when light travels through different media, it does change speed. And when we quote the speed of light, we're talking about the speed of light in a vacuum, for instance, going across space where there's less than one atom in every cubic meter. But when light passes into a more dense medium, that could be water, it could be glass, it could even be the Earth's atmosphere, it does change speed, it slows down. And scientists have managed to do experiments where using extremely cold, dense arrays of atoms, you can slow light down to walking pace, believe it or not. But what that doesn't mean is that you can wind the clock back, because although that light contains information about the thing that it departed from or the surface that it left from a certain period of time ago, and therefore you can see back in time by looking at what's in that light, you obviously can't go back in time beyond the point at which you were capturing that light. We can see back in time across the universe to quite close to the Big Bang because, as you alluded to in your question, because the universe is huge and light has been travelling across the universe for an extended period of time, and the universe is also growing at the same time, it's having the effect of stretching out the light, but we can still see some of that light, and we can infer from patterns written into that light what conditions must have been like when that light was first issued from wherever it came from across the universe. So in that respect, we can see back in time, and we can see back 12, 13 billion years. But there is a period right at the very beginning where we can't get back beyond, because there are various reasons that it's very difficult to see any further than that. But we do get enormous amounts of information by looking at great distances and light that's come a long way across the universe, because that's some of the earliest light that was produced in the universe.
Ian, satisfied?
Thank you very much.
Really appreciate it. Quick question. Yeah, I love it when we have astronomical questions. Chris, why doesn't the moon rotate?
Well, the moon does rotate, and the moon is rotating at just the right rate so that as it completes one orbit of Earth, it turns at one complete circle. This has the effect of meaning that the moon always shows us the same face. And perhaps this is what the person who asked the question is alluding to, because the moon doesn't appear to rotate. It always shows us the same face, and we somewhat incorrectly refer to the other side of the moon as the dark side of the moon. It's not dark at all, because of course at certain points in the moon's orbit around the Earth, it's pointing straight at the sun, so it's illuminated, but we can't see it. It's dark because we can't see it, but the moon does rotate. It just happens to be rotating for various reasons, so that the same face always points towards the Earth, because it does one complete rotation of it about its axis for every orbit it completes of the Earth. And if you do the experiment yourself, if you hold a tennis ball to be the Earth and a ping pong ball to be the moon, for example, and you rotate your hands in the right way as you move your hands around each other, simulating an orbit, you'll see that you can achieve a rotation of the hand with the ping pong ball moon in it, which is just right to keep the same face of the moon always pointed towards the Earth.
Chris, if melting ice blocks don't make the water level in a glass rise, how would melting glaciers make sea levels rise, Chris?
It's quite right that if you have ice floating in your glass of water, and it's up to the top of the glass. When the ice melts, it will not overflow, and the reason is that the ice is displacing or pushing out of the way a volume of water equivalent in weight to the mass of the ice. And the ice is water itself, and so therefore the floating ice will displace its own weight in water. Therefore, it's already displaced and contributed to a water level rise equivalent to the amount of ice. That's for floating ice. The distinction is what about when the ice is on land, because it's floating on the Earth's crust, but it's not floating on the water. And this is where sea level rise comes from. If we melt the Arctic, the North Pole, then most of that ice is sea ice, and so it's already displacing water and causing sea level rise. Therefore, if it melts, nothing will change. But when we have glaciers, for instance, and ice sheets on Greenland, we have the Antarctic ice sheet. Those are over land, they're over crust material. If they melt, then the water goes into the water, and it does lead to a sea level rise. So that's the reason.
Yes, I'll take a voice note as well, but I'd appreciate if you rather call in so you can ask your question directly to Dr. Chris Smith, the Naked Scientist. Let's have a listen.
Morning, Chris. I'm interested to know your take on, or opinion on, chaos theory and nonlinear dynamics, and more specifically, the consequences of, or implications of that theory on our current Newtonian paradigm, being very linear. A causes B causes C. Hoping that makes sense. And the reason I ask is, when reading up on it, the two seem very juxtaposed, and the latter seems to undermine quite a bit of the former. Thank you. Johan from Capri.
Please explain, what is chaos theory, Chris?
Well, let me simplify by saying that when Isaac Newton, who is a famous physicist back a few hundred years ago, working in Trinity College, Cambridge, roughly where I am, he envisaged and used maths to work out quite an elegant solution to explain how things move around the universe, for example. So if you've got planets going around the sun, if you've got people standing on Earth, apples dropping out of apple trees, there is a way of working out how they move based on his laws of motion and some mathematical calculations. And for the vast majority of things, that works very well. But when you then take it to extremes, either things that are extremely big or things that are extremely small, it breaks down. And this was one of Einstein's insights. And he pointed out that actually when you get to the very, very big or the very, very small, then Newton goes wrong. It's off. And there's various reasons why it's off. And this means we have to invoke other forms of physics in order to account for these extremes. And some of Einstein's experiments showed that why Newton was off when he did famous things like gravitational lensing experiments and so on. So Newtonian physics is very good for the vast majority of situations and accounts for how things work, and it's a good rule of thumb. When we go to extremes, then we need to use other methods, and this is where the quantum realm comes into play. For example, at the tiny scales and massive scales, we're dealing with the stars and black holes and so on. You need to work slightly differently. Now, why we get these differences and why we get these disparities, we don't have a grand unified theory of physics. In biology, we do. It's Darwin's theory of evolution by natural selection. We don't have the equivalent in physics, which currently marries together all of the different branches of physics and why things have mass, why mass causes gravity to happen, how gravity travels and is propagated through the universe. We don't have a way of bringing together all these different branches of physics. And so at the moment, we have ideas, we have theories, and we have ways of making it work. But we can't account for why some aspects of physics are the way they are at the moment.
Is it related to what we call the butterfly effect, that a butterfly flapping its wings in South America somehow just gets bigger, and then results in the tornado in Tornado Alley somewhere in Kansas? Is that related to that?
Well, it came from Jurassic Park, didn't it? Where the guy who was a chaos theoretician, I think, in the story or in the film. Yes, I mean the idea is that you have one perturbation in one place that then has a knock-on effect, which then causes the whole thing to then change slightly and something else to happen, and all these knock-on effects slowly end up being one massive outcome. But to be honest with you, it's very hard to model all of this because there are so many millions and billions of possibilities that it's impossible to say it's wrong, but it's also impossible to say when this is going to happen.
Zuki in Big Bay, I see you, but Passad in Constantia, good morning.
Morning, Lester. Hi, Chris. My question to you is in two parts. Number one, what's the scientific view on acupuncture? And the second part of it is fish therapy, particularly for the foot, where the fish come and nibble and presumably eat away the dry skin. What are your views on it?
I've had that. Thanks, Passad. I've had that on the trip to Thailand. You put your feet in a little tank, and the thought is they nibble at all the dead parts of your scaly and bunion-filled feet, and it has properties that will give you smooth and soft baby-like feet.
Speak for yourself, Lester. I've got lovely baby smooth feet already. And if you believe that, you'll believe anything. First of all, acupuncture. Well, for anyone who's not familiar, this is the idea of sticking very fine needles into certain parts of the body, and that has the effect of stimulating the nervous system, and this has the effect of achieving various physiological outcomes. Now, on the one hand, there's a whole lot of folklore around this, and probably some bunkum, and a story that improves from the telling. On the other hand, there is a sound physiological reason for seeing and saying why this would make a difference. The whole business of stimulating certain nerves to achieve certain outcomes in the body, I think, is probably a bit debatable. But the whole principle of if you stick something into the skin and stimulate one class of nerve fibres, you can change the way that others behave. That's absolutely sound physiology and neuroscience, and researchers know that that's absolutely the fact. We've got really good evidence to support it. So the idea is that, and this is based on different types of experimentation, if you stimulate certain classes of nerve fibre in the skin or other parts of the body, usually the ones which are what we call low threshold big mechanoreceptive nerves. In other words, the ones that you would invoke by rubbing or stroking skin, for example, those ones can turn off the flow of pain through fine caliber pain fibres, which you would normally stimulate with, say, a burn or injury to a piece of tissue. And this is called the gate theory of pain. It's the same reason that if you stub your toe, you were just talking about feet, then you would rub the area and get relief. If you hit your thumb with a hammer, what do? You put your thumb in your mouth and give it a good suck, unless it's covered in grease or something, of course. And the reason you do that is you are stimulating the low threshold non-pain nerves with the stroking or rubbing or sucking, and that then inhibits the flow of pain through the pain fibres. So acupuncture may well do similar sorts of things when you use it. It's also very relaxing. It involves interaction between two people, a sympathetic practitioner who will perhaps listen to a person who's also sharing some problems and so on. So people do find it's physiologically and psychologically a useful thing to do.
And that brings in the concept, of soothing. So if a kid falls or knocks its head, there is the emotional, psychological soothing of the mom and dad, kissing the forehead or the ouchie, and also at the same time giving it a little bit of a rub, and that, as you say, stimulates that particular, or inhibits the pain in that particular part.
I think you've got the psychological rub and stroke that you get from some aspects of comfort, and then you also get the physiological prod and rub you get from things like either acupuncture or rubbing the area better. Now, to feet, if you think about it, this is the sort of behaviour that these fish do in the wild anyway, because the world of nature and the marine realm is full of examples of fish that provide cleaning services to other fish. Fish don't have arms and legs, so they can't just easily reach around and pull parasites off or dislodge bits of muck that have got stuck to them. So they visit cleaner stations, and there are other fish that will pull off the parasites and clean up the skin surfaces of bigger fish, and in return they get, to a certain extent, food and nutrition. They also get protection, safety in numbers, and the big fish scares off fish that might eat the small fish. So when you put your feet in a bowl of hungry fish, basically the fish are pulling off the bits of dead skin. That's protein. They can digest that. Fish need protein to grow because their bodies are full of muscle. That's what fish skin and fish tissue is. So it suits them down to the ground to go and clean up your feet for you. They benefit, and so do you.
Zuki, thanks so much for your patience in Big Bay. How are you?
Good morning. I'm fine, thanks. How are you?
I'm very good, thanks. What's your question?
Okay, first, happy birthday for the weekend,
Thank you.
and then, and then, Dr. Chris. I see these collagen powders and pills seem to have become very popular. So I want to know: are they proven to be as effective as they claim? Are you able to get enough from just ingesting powders and pills, or is it just another fad?
Or you could have a wife who regularly boils broth and all the bones and all the little cartilage bits in the pot, and your house smells like just like bony broth, and then somehow freezes that and puts it in little ice cube trays, and then it gets added to every meal. Thanks, Zuki. But the supplement industry, Chris, with collagen and those type of things, are they viable?
Right. Collagen is a protein, and it's one of the main connective tissue proteins in your skin, in your muscles, in your tendons. And the reason our skin has the shape, texture, and structure that it does is because of largely collagen, but also elastin, the elastic tissue. And the ratio of the two gives your skin its texture and its characteristic. And as we get older, we tend to lose both, but we also tend to get more collagen and less elastin. The ratio changes. So your skin tends to become less elastic and springy as we get older, and therefore it's more likely to form wrinkles and furrows and so on, which might have people resorting to facelifts and injections of Botox. But because it's a protein, your digestive system is really very good at digesting protein. That's what happens when you eat meat. And it goes into your stomach, and there are protein digesting enzymes in the stomach. There are more protein digesting enzymes in your small intestine from your pancreas. This dismantles all the proteins that you take into your body and reduces them down to their individual building blocks called amino acids, or occasionally groups of amino acids. They're very short chains, 2 or 3 amino acids maximum. And they're then absorbed into the body and ferried around the body where cells pick them up, a bit like a conveyor belt in the sushi bar, bringing around different foodstuffs to make your meal. Cells will use the bloodstream as that sushi bar conveyor belt. They'll pluck out the things that they want, bring them inside the cell, and then make stuff from them. All the building blocks that they need are delivered on tap like that, but they're not delivered as whole proteins. They're not delivered as whole chunks of collagen. So eating collagen just because it's collagen is not going to help. Eating a balanced diet that has the right amount of protein in it, the right amount of other essentials that you need, carbohydrates, fats, micronutrients. It's a healthy diet that's a balanced diet that represents all the main food groups that's really useful. A lot of these supplements are actually just benefiting the wallet of the people who sell them to you, and they're not helping you at all.
Kathleen in Plumstead, good morning. How are you?
Good morning. Lovely program. Good morning. My question is, what is light therapy? What does it do? What is it?
I've never heard of it, Chris.
Hi, Kathleen. Well, light therapy can mean different things to different people. I'll start with the simple one, which is, and because we're getting to the point where in the Northern Hemisphere, people are going to be thinking about changing the clocks soon, and we're going to go into a phase where we have very short days, sun sinks early in the day, rises late in the day, and people get seasonal affective disorder, SADS. And this is where, when they are subject to changing clocks, but also long nights, dim days, not enough sunshine, people get these depressive symptoms. And it's very common. Maybe a third of adults get some kind of SAD syndrome. And there's one form of light therapy where people buy a light box and they eat their breakfast, they go about their business during the day with a bright light on them. And early in the morning, festooning your body and deluging it in a big surge of bright light has a very positive effect on the symptoms of seasonal affective disorder. It helps to reset your body clock for various reasons, and it helps people to bolster their mood. So that's one form of light therapy. There is a different approach, which is called photodynamic therapy or phototherapy, and there are certain conditions where we give people exposure to light in order to treat underlying health conditions which are more organic conditions rather than psychological or neuropsychological problems. One example of that would be psoriasis, for example, which is a condition of the skin. And we sometimes give people a photosensitizing agent, which goes around in the bloodstream, gets distributed to all the tissues, and then they go into effectively where you put someone to get a suntanning room, and you give them ultraviolet A exposure, and this goes into the skin, activates the drug that you've given them, and that drug is only activated where the sun or the bright light shines, so therefore you can restrict which bits of the body you treat, but chiefly it's going to go into the skin because that's where the light is. The active drug then has its effect on those cells. And if it's a skin condition like psoriasis, then you're effectively treating just the skin. You're not giving systemic therapy throughout the body, which could harm other tissues that don't need to be touched because they're not affected by the condition. So it's one way of directing the therapy. So we do this for a range of conditions, and psoriasis is a common one.
If the body synthesizes ultraviolet light, Chris, and synthesizes that into vitamin D, based on our previous question on collagen, where does the vitamin D supplement industry lie in this conversation?
Well, what happens with vitamin D is this is actually a hormone. We also call it a vitamin, but it's a hormone. You can't make it in your body, and it has a really profound role in helping you to mobilize calcium around the body and absorb calcium from your diet. And without adequate vitamin D, you will become calcium deficient, and this means you dip into your skeleton for your calcium supplies, and it weakens your bones. So having adequate vitamin D is a good thing. You make most of the vitamin D that you need from the sunshine, and about 15 to 20 minutes of sunlight on exposed skin. You do need a bit more with darker skin than white skin, but that's about what it takes per day of good quality sun exposure, and this will make vitamin D, or at least it makes the precursor of vitamin D in your skin. Now, there are some people who live in some parts of the world where there's not enough sunshine for some of the year, and places like the UK, you will find that the majority of people come the end of winter will be vitamin D deficient. So under those circumstances, bolstering your vitamin D intake can be beneficial, and some people are urged to take vitamin D supplements for that reason.
We have space for two more questions. Sue in Tableview, I see you, but Wilhelm in Belleville was first. Very quickly, Wilhelm, how are you doing?
Okay, fine, thanks. And Dr. Chris, we know the Big Bang happened, and everything expanded after it. But do we know, for instance, where the center of the universe is, or for instance, in relation to the Milky Way? And my second question is, when our sun and planets formed, did the sun first happen and then the planets, or did it happen simultaneously? And how did our planets at those specific distances in their orbits from the sun, how did it happen at those specific distances?
Well, let's start with the planets and the solar system first, and then get on to the universe after that. So the way this works is that in our patch of the universe, in our galaxy, the Milky Way, there would have been a huge cloud of gas and dust. This would have been about 5 or 6 billion years ago. We think that in our cosmic neighborhood, another star exploded in a supernova, and this created a shockwave which pushed some of that gas and dust together and gave it enough of an inward momentum that it began to, under the effects of gravity, collapse in on itself. As the gas and dust got closer and closer together and rubbed up against itself and squeezed together under gravity because it was huge, it would have eventually formed a big enough ball that was big enough, hot enough, and gravitationally powerful enough to ignite as a proto-star, and that was the baby sun. So that would have come first. All this gas and dust is turning and spinning because everything in the universe is in motion, and you can't not move. You can't stop moving. So you add together all of the relative motions of everything, and you end up with the ultimate direction of travel of all the things that are together in one place. And so we end up with a proto-star, the sun to be, that's turning, and a pool of gas and material around it from which it formed that's also turning. Because of the rules of physics and conservation of angular momentum, that stuff eventually is going to sink into a sort of ring system around the star, a bit like the rings of Saturn, and in those rings there is localized aggregation of material which, because it's got a bit more gravity, is going to pull more material together into baby planets called planetesimals, and they're going to slowly vacuum up all the material in their patch of the orbit and slowly pull it all together to make bigger and bigger planets. And then the gravitational interactions between them all are going to pull them into a stable configuration over the evolution of the solar system. And so our planets would have jockeyed around a bit, moved about a bit to start with, until they settled down into a stable series of orbits that we see today. So that's that answer. And maybe we'll save the "are we at the centre of the universe" in the Milky Way for next week.
Excellent. Quick question. Elroy, what's his name? Yes, Roy wants to know just what you eat in a day. That's somebody. Let's ask Chris what he eats in a day.
Well, I always start with breakfast. Breakfast is the most important meal of the day. So I always have a decent breakfast, often cereal, but sometimes bits of toast if I'm in a hurry. But I always try and have some breakfast, sandwiches for lunch, and then a decent dinner in the evening. And if it's a Friday or a weekend, or there's any decent excuse, then I'll get a decent ale out of the freezer or that I've had in there chilling, and quaff some of that down. A little bit of beer helps, doesn't it? It goes a long way.